Earth, a unique planet restless and dynamic, continents shift and clash. Volcanoes erupt, glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. Let's travel back in time to investigate the greatest geological mystery of all, the birth of the Earth. It all begins with a big cloud of gas and dust, little particles of dirty matter, grains of sand and silicone. Scientists call these regions of dust and gas molecular clouds, but they're not like any clouds we've seen on Earth. It covers hundreds of light years in size, made up from the debris of hundreds of dead stars when it blew back into the galaxy. A large molecular cloud had a small rotation. When it shrank, this rotation sped up. As the cloud contracted, the energy of the material flying in from space, causing its center to heat up. The spinning ball in the center became our sun. The rest of the cloud was spinning so fast that it spread out into a vast disk of gas. This was the cradle of life, the material that would form the Earth and all the other planets. But what turned this dust into a planet? How could colliding microscopic mineral grains ever create an object the size of a planet? Then, in March 2003, an experiment on board the International Space Station accidentally provided extraordinary new evidence. Astronaut Don Pettit was curious to see the effects of weightlessness on the different substances in the zero-gravity condition of space. He filmed bubbles, indigestion tablets, swirls of colored water, then poured some salt into a plastic bag and began shaking it. This last experiment turned out to be a scientific revelation. The particles immediately began to stick to each other, forming little clumps all held together by tiny static electric charges. Scientists realized that if grains of salt stuck together in space, then so could the mineral grains in the solar dust cloud. That was real evidence for the fundamental mechanism that kick-started the formation of the Earth. As mineral grains in the solar dust cloud bumped into each other and stuck together, they grew into small pieces of rock orbiting the sun. Over the next few million years, some of them collided and grew bigger into around 20 planets. As these 20 planets orbited the sun, their gravity affected each other and they began to collide. With each collision, the two planets combined. Over time, these collisions reduced the inner solar system to just a few planets, including Venus, Mercury, Mars, and Earth. Astronomers believe that the Earth grew to this stage in around 30 million years. The young Earth was made of billions of pieces of rock randomly stuck together. But geologists know that the modern Earth is not like that. Below the surface, the Earth is separated into distinct layers, a thin crust, then a massive dense layer of rock called the mantle, and at the center, an iron and nickel core. Soon after it formed, the Earth completely melted, and when that happened, the denser elements sank down through to the very core of the Earth, and the lighter elements floated at the top, separating the rest of the planet into layers. The spinning motion of the core creates a magnetic field that gives our planet its north and south poles, far out into space. It's called the magnetosphere, and this is what protects us from the solar wind. In less than a million years, Earth's surface was covered in a thin crust, but volcanoes still spewed out lava and choking gases. Meteorites still rained down in a constant bombardment. Earth had a long way to go before it could support life. There's still no oxygen or water on Earth. Astronomers suspect that asteroids brought water to Earth in a torrential shower of meteorites, and the culprit appeared to be the biggest planet in the solar system, Jupiter. In the distant past, it pulled thousands of asteroids out of their normal circular orbits into elliptical orbits that crossed the path of the Earth. And collisions were inevitable. The Earth was bombarded. As the asteroids crashed to Earth, they smashed apart. Water inside them escaped. Explosion by explosion, they created the oceans we see today. Once Earth had landed masses and water, the stage was set for the development of life, the next phase in the evolution of Earth, beginning with an ocean rich in iron which would have appeared green. As the bacteria were a stromalite, bubbled out oxygen, it reacted with the iron in the water to form iron oxide, and it precipitates out as rust. There was so much iron in the oceans that for over 1 billion years it absorbed nearly all the oxygen that the stromatolites produced. As the rust precipitated it out, it fell to the bottom of the ocean and was turned into rock. At that time, our Earth reached the level at which animals could survive. In Earth's story, our motherland still has a long way to go before the first humans will walk on its surface. It has taken over 1 billion years, but out of vast freezing dust and gas, the forces of nature have created the only safe haven we have in the universe. Our home, the Earth.